You know that filter you just slapped on your latest selfie? Well, believe it or not, that's basically the same tech that lets us peer into galaxies billions of light years away. Today, we're going to pull back the curtain on digital image processing, the incredible science of teaching our pictures how to see. Okay, so let's start with something we all know. We've all done it, right? You take a perfectly fine photo, you swipe through a couple of filters, and boom, your boring picture of lunch suddenly looks like it was shot on vintage film, or it's some kind of vibrant pop art. It really does feel like magic, doesn't it? So you start with this, a totally normal picture. And then, with just one tap, it completely transforms. The colors get richer, the contrast just pops, and the whole vibe of the image changes in an instant. But what's really going on in that little split second? Well, here's the spoiler. It's not magic at all. It's actually a really powerful field of science. And by the time we're done here, you're going to see how this so-called magic is at work absolutely everywhere, from your social media feed to the deepest, darkest corners of space. To really get how this all works, we first need to understand the raw material we're working with. I mean, what even is a digital picture? Let's break it all the way down to its fundamental building blocks. So here's the most important thing to get your head around. A digital image isn't the real thing. It's kind of a beautiful lie. It's an approximation of a real scene. It's the world's translated into a language a computer can actually understand, and that language is built from tiny little things called pixels.
That's right. Every single stunning photograph, every meme, every little icon on your phone. If you could zoom in far, far enough, you'd see it's all just a massive grid of tiny, single-colored dots. Think of it like a giant mosaic where millions of little tiles come together to make one big picture. Each one of those little tiles is a pixel.
And if the pixels are the nouns of this language, then digital image processing, or DIP for short, that's the verb. It's the action. It's all about using clever computer algorithms to mess with all those individual pixels to get what we want, whether that's making a photo look way better for us to look at or pulling out some specific information for a machine to use. Now, this is a really key distinction to make. There's image processing, and then there's a related field called computer vision. With image processing, the final product is usually an image that's meant for a human to look at, like that cool filter on your photo. But with computer vision, the output isn't a picture, it's data for a computer to act on. For instance, a self-driving car doesn't just see a pretty picture of a stop sign. It extracts the meaning of that stop sign, so it can actually hit the brakes. Now, this tech might feel super modern, like it just showed up yesterday, but its roots go back surprisingly far. We're talking almost 100 years. Its story is actually woven into the history of communication, space exploration, and even medicine. It all started way back in the 1920s, with newspapers trying to send these grainy, black and white photos across the Atlantic Ocean through giant underwater cables. Then, fast forward to the space race in the 60s. NASA was using these same ideas to clean up the very first fuzzy close-up images we ever got of the moon. In the 70s, it gave us the CAT scan, literally a window into the human body that won a Nobel Prize. And then once computers got powerful enough in the 80s and beyond, it just exploded into every corner of our world. So, okay, we get it. It powers our photo filters. But where else has this technology been a total game changer? The applications are honestly staggering and, in some cases, have literally saved billion-dollar projects from total failure. This is, hands down, my favorite example of just how powerful DIP is. So when the Hubble Space Telescope first launched, it turned out its main mirror had a tiny, microscopic flaw, a $1.5 billion mistake that made all its pictures blurry and basically useless. But instead of a crazy expensive mission to fix it, scientists on the ground developed these amazing image processing algorithms that could digitally correct the blur. They give the telescope perfect vision and save the entire project. It's the ultimate example of fixing a hardware problem with pure software genius. And remember the CAT scan? It's a true medical marvel. What it does is take a whole series of 2D X-ray slices of your body, and then it uses image processing to digitally stack them all up, creating a full 3D model of your organs, your bones, everything. It lets doctors see right inside you without ever picking up a scalpel. Image processing is also a huge player in modern law enforcement. It's the engine behind those systems that can automatically read a license plate number from a super grainy security camera video or match a tiny partial fingerprint found at a crime scene against a database with millions of prints in just seconds. Ever wonder how something like your smartphone is so perfectly made with no defects? Well, in factories all over the world, They're these industrial vision systems that use DIP to do things no human ever could. A camera can inspect thousands of products whizzing by on a fast-moving assembly line, spotting microscopic flaws with perfect accuracy, 24/7 without ever getting tired. And if we zoom out to a global scale, Geographic Information Systems, or GIS, rely completely on DIP. I mean, every single time you check the weather forecast or look at a satellite map on your phone, you are seeing the end result of incredibly complex algorithms processing raw satellite data to classify different types of land, track hurricanes, and even monitor deforestation in the Amazon rainforest in real time. So we've seen the what and the why. We've seen all these amazing applications. But how does a computer actually go from just a big grid of colored dots to something meaningful? Let's do a quick walkthrough of the typical life cycle of an image. Okay, so it usually happens in a few steps. First up is acquisition. That's just your camera's sensor capturing the light and creating the image. Then comes enhancement, where algorithms might sharpen the image or adjust the brightness and contrast to make it clearer. Next is segmentation, which is a cool one. That's where the software tries to divide the image into its different parts, like figuring out where the person ends and the background begins. And finally, you get object recognition, which assigns a label saying, okay, this blob of pixels is a person, and that collection of pixels is a tree.
There's that old saying, a picture is worth 1,000 words. But I actually like the version used in the source for this explainer even better. A picture is worth more than 10,000 words. And it's so true. Images are just this incredibly dense, rich form of information.
For almost all of human history, pictures were just things for us to look at. But that's changing. We are now actively teaching our pictures to see for themselves. So it leaves you with a pretty big question. If one picture is worth that much information, what new discoveries, what new solutions, what new worlds are we going to find now that we can finally unlock the knowledge hidden inside the billions of images we create every single day?